Okay, so here's one of the variable acceleration questions. So we have got a particle which moves on the x-axis at time t seconds the velocity. So this is our velocity equation. Is v meters per second in the direction of x increasing. So that means in that direction, where we're given the velocity equation and t is greater than 0. So A, the times when p is instantaneously at rest. Well, p is instantaneously at rest when the velocity is equal to 0. So all we need to do is solve our quadratic for 0. Okay, so A is equal to 2t squared minus 14t plus 20 equals 0. So now if I put that into my calculator or factorize, whatever you want to do, I get that t is equal to 2 or t is equal to 5. So that's instantaneously at rest. Easy. Second part, the greatest speed of p in the interval from 0 to 4. Okay, well, so there's, if I think about this, my velocity is basically, it's a quadratic. So if we look at the quadratic, that's my velocity. So what I'm looking for is the point where it's at its greatest between 0 and 4. Well, it looks like it's here at 20. Okay, so that's from the graph. Because remember, basically, that's a quadratic, so it's going to basically be dipped down. So that's going to be here, speed. This, remember, the velocity is minus 4.5, but the speed is a magnitude. Okay? But here, it's plus 20. So let's go back to the algebra. So now, if I take the change in speed, I get acceleration. So let's differentiate it. I get 4t minus 14. So if I make 4t minus 14 equal to 0, I find that t is equal to 7 over 2 or 3.5. Okay, so now that is telling me the turning point. Okay, it's telling me basically when my velocity stops decreasing, becomes 0, and then starts to increase. So that's basically showing me that turning point on my curve. So if I include the acceleration curve, you can see that the root for that is here. Or we could have thought, basically, if I've got the roots of 2 and 5, the root of the acceleration has to be halfway between, because that is my turning point. Okay, but now if I go back and look at my if I look at my turning point, now remember basically this is a turning point. If I sub my turning point back into my equation, so if I have 2, 7 over 2 squared minus 14, 7 over 2 plus 20, and I sub that in, I actually get minus 9 over 2, which is negative. But that's, if I take the absolute value of that, the speed is 4.5 meters per second. Okay, but if we look at our velocity, we know that our velocity equation, when t is equal to 0, that's equal to 20. And again, from our graph, if we look at our graph, here's the maximum, it's at 20. So between 0 and 4, the maximum speed is 20 meters per second. Okay, now the last part. Now we want the total distance travelled by p in the interval between 0 and 4. Now we don't have an example, so remember, if we want the distance travelled, it's the area under the velocity time graph. Okay, so I'm going to take my velocity and I am going to integrate it with respect to t. So I'm going to do the integral of 2t squared minus 14t plus 20 dt. And I am going to use the limits of 4 and 0. because if I do an indefinite integral without limits, I have to find c, and I have no example here to find c. So right, so I do 2t squared, well, comes t cubed, and then I divide by 3, so I've got 2/3 t cubed. I've got minus 14t, or t becomes t squared, and then I divide by 2, so that's minus 7t, and I've got 20, and that actually becomes 20t, and I have to evaluate that from 4 to 0. Now remember, a good idea is always to have, when you're substituting in your limits, 2 brackets. Okay, the first bracket is going to be where I substitute in 4, and the second bracket is going to be where I substitute in 0. So as you can see, all of the terms are t, t, and t, so the second bracket is just 0. And the first one is 2/3 of 4 cubed minus 7 times 4 squared plus 20 times 4. Okay, and when I do that, my answer is 32 over 3. And again, if we go back to our graph and try and think about this, so displacement is like that. So displacement is a cubic, and if I go to between 0 and 4, I'm getting the area under this curve. Okay, so that's my, and again, if you think about velocity time, there's my velocity. Okay, so I'm looking for the area between 0 and 4. Okay, I hope that helps. Don't get confused about turning points. Remember, basically, if we differentiate we differentiate displacement, we get velocity. When velocity is 0, that means that it's instantaneously at rest, and that means that our displacement is no longer changing. So it's a stationary point for displacement. If I differentiate my velocity, I get acceleration. When that's equal to 0, that means that my speed has stopped changing, so it's a stationary point for speed. So remember, always, if you differentiate and make it equal to 0, you're finding a turning point. It may not be the maximum within the range. You need to check that. Right, hope this helps.